In this video, they want us to find the area of the pink shaded circle. So as you can see, this is the circle which is inscribed inside this quadrilateral that has this as 90 degrees, this 90 degrees, this upper side length is 9, and the downer side length is 21. So with that information, what is the area of this circle? So first, let's start by labeling the points on our figure. Let this be A, let this be B, C, and this D. As you can notice, this quadrilateral that we have ABCD is a tangential quadrilateral because its sides are all tangent to a single circle within the quadrilateral. So all the sides of the quadrilateral are tangent to the circle at this point, at this point, at this point, and at this point. So it's a tangential quadrilateral, and that's where the Pitot theorem comes in now. With the Pitot theorem, it says that in a tangential quadrilateral, the sum of its two opposite sides are equal. So by that we mean that AD plus BC is equals to many of you have tried correcting me in the previous video saying is equals to is wrong grammar. So I'm going to try and correct it, though I had been used to it. So what we mean by the Pitot theorem is AD plus BC is equal to AB plus DC. Okay, so we are saying AD plus BC is equal to AB plus DC. So this is the Pitot theorem. So let's call this equation 1. Next step, let's draw a vertical diameter passing through the center, of course, of this circle. So let's draw a vertical diameter. So we have drawn this line and we can see it's passing through the center and it's the diameter of this circle. As you can see, from here to here is radius and it's tangent to this line. Therefore, from the tangent to circle theorem, this implies that this is 90 degrees. This is also 90 degrees. Now let's say the radius of the circle is r. So from here to here will be r. Also from here to here will be r. Let me call this point E and this point F. So that means that EF is r plus r, which is 2r. And since this is 90 degrees, this is also 90, this is also 90. Since we already know that this is 90 and this is 90, that makes shape AEFB a rectangle. And we know that opposite sides of a rectangle are equal. So AB is equals to EF. AB is equal to EF. And we have already seen that EF is 2R. Therefore, also AB is equal to 2R. So this side here is 2R. So now going back to our equation 1, which was AD plus BC is equal to AB plus DC. As you were given already, AD is 9. So 9 plus BC is 21 is equal to AB, we said is equals to EF, which is 2R. So this is 2R plus DC, which we don't have. So we make DC the subject. So DC is equal to 9 plus 21. When this crosses, it becomes minus 2r. And so DC is equal to 9 plus 21 is 30 minus 2r. Therefore, this line DC is 30 minus 2r. Next, let us draw a perpendicular line from point D to line BC. So we're drawing a perpendicular line here, just like that. Since it's perpendicular, this is 90 degrees. And since this line is parallel to this line EF, and EF we know, and so we've come up with a rectangle also. So this side EF is equals to side D. Let me call this point G. So EF is equals to DG, so this is also 2R. We have this point AD is equals to 9. So meaning also BG, since this side AD is equals to BG, since AD is 9, also BG is also equal to 9. So if BG is equal to 9, then GC is equal to BC minus BG. So GC is equal to BC is 21 minus BG is 9. So this is equal to 21 minus 9 is 12. So from here to here is 12. Just like that. As you can see, we come up with a right angled triangle DGC. So let's focus on triangle DGC. So this side DG is 2R. This is 90 degrees. This side GC is 12. And this side DC is 30 minus 2R. Since it's a right angled triangle, we are going to use the Pythagoras theorem to solve. So we shall have a squared plus b squared is equal to c squared. Our a is 12, our b is 2r, and our c is 30 minus 2r. So replacing, we shall have 12 squared plus 2r squared being equal to 30 minus 2r all squared. So this is 144 plus this is 4r squared is equal to, when you expand this, you'll get 900 minus 120r plus 4r squared. So we have 4r squared here, also 4r squared on the other side, so they cancel out. So we're left with 144 is equal to 900 minus 120r. We make 120r the subject, so we shall have 120r is equal to 900 minus 144. 120r is equal to, this gives us 756. Divide both sides by 120 and r is equal to 63 over 10. So now that we have the value of the radius of the circle, we can now find its area. We know that area is given by pi r squared. So we shall have pi, our radius is 63 over 10. All this is squared. And so this is 63 squared gives us 3969, and 10 squared gives us 100. So this is times pi. So this is equal to This here gives us 39.69. So times pi. Pi is equal to 3.14159. So when you multiply these two, you get an approximate value of 124.69. And since this is area of the circle, it's in square units. So this is how you find the area of this circle that is inscribed inside the quadrilateral ABCD. Thank you so much for watching. Kindly subscribe to this channel for more amazing videos. Like, comment, and share your thoughts about the video in the comment section. And also, if you have alternative approaches, you can share them in the comment section. Thank you. Do not forget to share the video with your friends and family for an enlightening experience.